We will be starting a new chapter today, chapter 2, about triangles, and specifically Pythagoras theorem. As you know that triangles are of different types. We might have isosceles triangles, equilateral triangles, right triangles, and scalene triangles. Today we will focus more on right triangles and on Pythagoras theorem because Pythagoras theorem is only related to right triangles. What is Pythagoras theorem, how to apply it, and how is it related to right triangles? Those are our objectives for today. You are given here a right triangle. Why is it a right triangle? Because you can see here we have a right angle in 90 degrees. That's why this triangle is a right triangle. Now before we start with Pythagoras theorem and what is it, I need to label the sides of this right triangle. Whenever you have a 90 degrees, you look at the side that is facing this 90 degrees, and we call it a hypotenuse. This is known as a hypotenuse. Now, the other two sides of a triangle that are different than the hypotenuse, those two sides, they are called the legs of a triangle. This is a leg, and here we have another leg. Now, the most important thing in a right triangle is to identify the hypotenuse. Let's take another example. This is also a right triangle because as you can see here, we have a 90 degrees. Now we need to label it. We need to identify who's the hypotenuse and who are the legs. As we said, the side that is facing the 90 degrees is known as a hypotenuse. So this side is labeled as hypotenuse. And the other two sides, they are known as the legs. Another example, a right triangle. Why is it a right triangle? Because as you can see here, we have a right angle. Let's label the sides. The side that is facing the 90 degrees is the hypotenuse. And the other two sides, they are the legs. This is a leg and this is a leg. Why are we labeling it and why are we identifying the hypotenuse? Because this will make it easier for us to apply the Pythagoras theorem. And I want you to keep in mind that always a hypotenuse in a right triangle has the largest or the longest measure, the longest length. Let's take an example here. As we said that the one that is facing the 90 degrees is the hypotenuse, and we agreed it has the longest length, and this is a leg and this is a leg. Now, it is commonly known that the hypotenuse has a measurement c. We will give it the letter c, and c is always used, so the hypotenuse has a measurement c. And the leg, one of them has a measurement a and the other has a measurement b. The most important thing is to identify c. C is always for the hypotenuse or for the longest length. What is it, the Pythagorean theorem or Pythagoras theorem? It says that c squared, which is the length of the hypotenuse to the power of 2 in a right triangle, is always equal to the measurement of one of the legs to the power of 2 plus the measurement of the second leg to the power of 2. This is the Pythagoras theorem and this is fixed for any right triangle. Given the following example, use the Pythagoras theorem to determine whether the following triangles are right triangles. We are given a triangle with random side measurements, 13, 12, and 5 centimeters, and they're telling us, is this triangle a right triangle? To determine whether it's a right triangle or not, the only way is to use Pythagoras theorem. Let's write down Pythagoras theorem. It says that c squared is equal to a squared plus b squared. We agreed that c is the length of the hypotenuse. If I do not know which one is the hypotenuse, c is considered the longest measure. So I look over here, 12, 5, 13. The longest measure is 13. So definitely 13 is C. So 13 is C. Now, 12 and 5, one of them is A and one of them is B. It doesn't matter who's A, who's B, as long as you identify C. because c is the most important measure. We come over here to the Pythagoras theorem and we say that c to the power of 2, this means 13 to the power of 2, is it equal, because I'm testing it, to a to the power of 2, 12 to the power of 2, plus 5 to the power of 2. We check. 13 to the power of 2 using your calculator would be 169. Is it equal? 12 to the power of 2 is 144. 5 to the power of 2 is 25. We continue. 169, is it equal? 144 plus 25 using your calculators is 169. So we obtained two values that are equal to each other. So this statement here is true. Then the Pythagoras theorem is applicable, is true here. When the Pythagoras theorem is true, this means that this triangle is a right triangle. Another example, tell whether this triangle is a right triangle. Our test for a right triangle is the Pythagoras theorem, which is c squared is equal to a squared plus b squared. Step number 1 is identifying which side is c. We agreed the longest length is c. We compare 6, 12, 15. The longest here is 15. So 15 centimeters is our C. And then it doesn't matter which one we consider as A and which one as B. This one is A and this one is B. Again, A and B could be the other two measures as long as you determine C the first place. C here we have 15 to the power of 2 is equal to 12 to the power of 2 plus 6 to the power of 2. Again, they are not equal. We are testing it. Are they equal? 15 to the power of 2, 225. Is it equal? 12 to the power of 2 is 444. Plus 6 to the power of 2 is 36. Then we continue. We have 225. Is it equal? 144 plus 36, that's a 180. Of course, if you notice here, 225 is not equal to 180, then it is false. If it is proven to be false, then this triangle here that is given with the following measurements is not a right triangle because the Pythagoras theorem did not apply. To sum the rule up, Pythagoras theorem is our only test to determine whether the triangle is a right triangle or not. We try the Pythagoras theorem by choosing the longest length as c and the other two measures as a and b, and we test, is c squared equals to a squared plus b squared? If they are equal, definitely this triangle is right triangle. If they are not equal, then the triangle that is given is not a right triangle. Another type of question, determine whether the given length can be side lengths of a right triangle. So they gave us, without the shape of a triangle, they just gave us the length of each side. And we want to test whether those could be the side lengths of a right triangle. As we agreed, step number 1 is determining which one is C, and C is the longest measure. If you look over here, we have 0.8, 1.7, and 1.5. The longest is 1.7, so definitely we're going to take this as our C. So this is our C. It doesn't matter who's A and who's B as long as we identified C. Now, our test for a right triangle would be the Pythagoras theorem. So we are testing if c squared is equal to a squared plus b squared. C squared here is 1.7 to the power of 2. Is it equal? Why do we put the question mark? Because we are testing, we are not sure. To 0.8 to the power of 2 plus 1.5 to the power of 2. Using your calculators, 1.7 to the power of 2 is 2.89. Is it equal? 0.8 to the power of 2 is 0.64. and 1.5 to the power of 2 is 2.25. We continue, 2.89, is it equal 0.64 plus 2.25, that's a 2.89. If you look over here, 2.89 and 2.89, the same value, so this statement is true. So the Pythagoras theorem applies here. So definitely those are sides in a right triangle. Another example, we have a set of length of 3 sides, and we want to see, do they make up or are they part of a right triangle or not? Let's first of all identify C, which is the longest length, 16, 29, 34. Definitely it is 34. This is our C. Now, as we agreed, A and B, it doesn't matter which one is A and which one is B as long as we identified C. Now, the only test for a right triangle is Pythagoras theorem. So we're gonna write Pythagoras theorem, c squared is equal to a squared plus b squared. C squared here, we're assuming it's 34 to the power of 2. Is it equal to 16 to the power of 2 plus 29 to the power of 2? Using your calculators, 34 to the power of 2 is 1156. 16 to the power of 2 is 256. Plus 29 to the power of 2 is 841. 1156, is it equal to 256 plus 841 is a 1097. If you look over here, the two values are different from each other. So Pythagoras theorem does not apply here. So here it is false. So this means that the measures that we have, or the lengths that we have, they are not the length of the sides of a right triangle. So the triangle that is formed from those sides can never be a right